Hey everyone, today we'll be going over LeetCode problem 133, Clone Graph. This is another problem off the Blind 75 list, which is a list of problems commonly asked during technical interviews. In this problem, we are given a reference of a node in a connected, undirected graph, and what we want to do is return a deep copy of this graph. Now we're told that each node has a value, and it also has a list of neighbors. So we need to replicate all of this information in our clone graph. Now we need to create a deep copy of this graph, meaning that for each node, we must create a new node, a new object, and this new node will have the same value as the original node, and also the same connections to neighbors as in the original graph. Now to keep track of these clones that we are creating, these clone nodes, we will use a hash map, which will be called original to copy, and it will have as the key values the original nodes, and as the value it is mapped to, the clone node which we make. So what we will do is go through this graph using a depth first search and visit each node once at a time. We will go and create the copy node and then create the connections to its neighbors. So for example, we will start with node number 1. We have this node number 1 which we visit, and so what we want to do is create a clone. We will create a new node, and to represent that it's a new node, we will make it of a different color, so blue. This new node we will put to have the same value, 1, and because we are creating this copy, we want to map it in our hash map. So we will have as the key value the original 1, and as the value, we will have the clone we created for this node. After which, what we want to do is go and visit its neighbors and make sure that these connections are put in our clone graph. So we see that the 1 has a 2 as its neighbor. So what we will do is, once again, create a node which is a copy of the original 1 with the value 2, and then go and create the connection between the 1 and the 2. Therefore, once again, we create a clone node with the value 2, and we go and link the original node to the clone node in our hash map. Now we can create the connection between the 1 and the 2, because they are neighbors in the original graph, and so they must be neighbors in our clone graph. We will then continue on visiting the neighbors of 2. So for example, we will visit 3. Once again, we must create a node with the value 3 as a clone, make the mapping in our hash map between the original and the clone node, and then create the connection between the 2 and 3. After having created the clone and putting it in our hash map, we can make the connection between 2 and 3, which are neighbors in the original graph, and so they will remain neighbors in this clone graph. We will then visit a neighbor of 3, such as the 4, and do the same. After creating the clone, we can make the connection between the 4 and the 3, which are neighbors, and then we will move on to 4's neighbor, the 1. For the 1, we would check to see in our hash map if the clone has already been made. We would see that we already have the original 1 in our hash map, and so that means it is already linked to a clone node. So we do not have to create a clone for that 1 once again. However, we do need to complete the connection between the 4 and the 1, so we will make that connection. Afterwards, because we are doing a recursive depth first search, we would pop back up, and we would eventually return to that 1, which is the clone of the head of the original graph, and we would return this node as our answer. The time complexity for this algorithm is O of n plus m, where n is the number of nodes and m is the number of edges. In fact, we see that we need to go through each and every node and replicate the node, and then we also need to go and copy each and every edge to recreate this deep copy graph, because we need to make sure that all of the neighbors remain neighbors in this copy graph. We are now ready to write up the code. We can start off our algorithm by taking care of the edge case where we are given a null graph. So if the node is null, we can just return null because there is no graph to copy. Then we want to create our original to copy hash map. We know that we will be doing a recursive depth first search, and each time we will be traversing one node at a time. Now, if the node is already in our hash map, then what we can do is simply return the copy of that node. In fact, we know that we have already visited this node and we do not need to create another copy. Otherwise, what we want to do is create the copy. So we're going to say copy is going to be equal to a new node, which will have the same value as the original node. And then go and make that link in our hash map. So we're going to link the original node to this copy that we have just created. Then we want to go through all of the neighbors that this node has in the original graph. So we're going through node.neighbors, and then go and add these neighbors in the original graph to the list of neighbors in this copy node. So we're going to say copy.neighbors and append whatever is returned by the depth_search of the neighbor. And I just have a typo here, so it's append. And because we are appending whatever value is returned from the depth_search itself, we know that at the end of each depth_search, we are going to return this copy that we have created. So that when we return a copy, when going through the neighbors and adding it to our neighbors list, we can just pass in the value that is returned from the depth_search. And in our main function, we could just return whatever value is obtained when calling this depth_search. Let's make sure this runs. And we see that it works efficiently. Thank you so much for watching this video. If you enjoyed it, please like it and subscribe to my channel. I'll see you on the next one.